So, good afternoon, sir. So, now I will make the uh, schematic or the future simulation of the given flip-flop. So, first, I will um, search the different devices that I will use. So, let's have the 7 segment. Let's have the 7 segment. 7 segment display. The red one. Then let's have the button, push button. And the 74 LS08. The 74 LS04 or the hex inverters. Then the 74 LS21 or the AND gates with 4 input. Then the 74 LS11, the AND gate with 3 input. And we have um, 74 LS32 or the OR gate with 2 input. Then 74 LS73, which is the flip-flop. Then we have this 7400 or the NAND gate. Then we have, I will also use the OR gate with 3 inputs so that it's easy for me to connect and less to connect the wires, and also it is useful so that it's the what we call this AND gate or the gates that I will be using will be lessened. So I will use the OR gate with 3 inputs, 4 inputs, and 5 inputs for me to easier. So I think that's it. All the devices that I need to use. So now, first, I will put first the button. So I will put first the button. Then next is the flip-flop. Which will be using for flip-flops. So I have here 1, 2, 3, and 4. Then I will identify first the what is the letters of the corresponding flip-flop. So I will put a text here. It is W, then X, then Y, Z. Then I will arrange this. For me, too easy to identify, so I will put the letters here. Then I will put for also the NAND gate. The NAND gate or the 7400 here, the top. So that will easily connect here. Now let's connect the flip-flop to the I know no. First I will also put first the hex inverters or the NOT gate here. So put here so that it's easy for me to connect later. Three, four, three. So now after putting these hex inverters, I will now connect first the button and the flip-flop to the hex converters and to the NAND gate. So first I will put the ground for the button. I'll put the ground here for the button. So I'll connect here. Then next is I will connect this button to the center of this first flip-flop to the Z. Then this one I will connect the power that will be used. So I will put it here. So this I will connect this to the power here. Then after that, it's easily for me now to connect his flip-flop to the power since I put the power first here. Then connect it here, here. Then this NAND this first this the top here the this like this I will connect it to the X inverters. So for me to easily I will align this so that I will easily connect it. Then here, then this one also. After connecting this, now I will connect the AND gate. So this AND gate will be connected here, will be connected here. And after that, this will be connected connected here. Then this one will be connected to this one will be connected to here. Here, then this one will be connected here. Then this one will be connected also here. This one will be connected here. And this one connected there. Delete this wire. This will be connected here. Right here. Then this one will be connected. So So now let's see if all the flip-flops are connected to corresponding hex inverters. So I will trace it first. So I think it's okay now. So for me to easily identify, I will also put here, since it is the hex inverter, so it is supposedly W prime, the X prime, Y prime, and the Z prime. So so I think it's okay now that all the flip-flops are now connected to the inverters. So by the way, flip-flops is the purpose of flip-flops is to store the binary. Purpose of flip-flops is to store the binary, what we call this, data. Store the binary data. So, so that the counting will be continuous because it is the 0 to 9, what we call this, mm, 0 to 9 counting with 7 segment. So this flip-flop used to store the data that will be used. So now, let us, since I have the equation now, so for me to easily connect this, what we call this, um, gates to uh, the different, the 7 segment, the 7 segment, I will put first the 7 segment here, and then the equation of every letter from A to G, so that is it will it must it is easier for me to connect. So since I have the equation, so I will put first the different equation here, then connect connect it to the 7 segment, but to the 7 segment, so that it is easier. So now, since the first equation is A, and it has 4 different AND gates, so I will use the OR with 4 inputs, so that I will only use one OR gate. Then here I will put that here and put a label of A. So for example, the equation for letter A is, we have A is equal to W prime Y plus X prime Y prime Z prime plus W prime X Z plus W X prime Y prime. So after this, so since I have this equation now, drag this here for letter A. Then for letter B, I'll put it here. I will drag it later or arrange it later. So I will use also the for input OR gate here. Then I will put the equation for letter B. I will put first the equation so that um easily I will easily identify the connection later. So for B prime, we have B is equal to W prime plus W prime X prime plus X prime Y prime plus W prime Y prime and Z prime plus W prime Y and Z. So now next is let's have the third equation. Let's have the third equation here. So since third equation has 4 inputs, so I will also use here this. Then so on and so forth. So for this, I will time lapse so that um it will not after this for connecting the different wire. Later I will time lapse after because it will consume so much time, and so I will edit it for the time lapse later. So now let's put the third equation here. C is equal to W prime Y prime plus X prime Y prime plus W prime Z plus W prime X. So we have W prime Y prime X prime Y prime plus W prime Z plus W prime X. So here. Then I will connect it here so that it's easy for me later to check the functionality. Then for the fourth equation, we have 5 inputs. So I will use the OR input. I will use these gates so that I will use lesser gates. It's messy if there are so many, and I will what do you call this? It's hard to trace for the connections if I will have um, that checking later. So let's put the fourth equation here. So D is equal to W prime X Y prime Z W prime X Y prime Z plus 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 X prime Y prime z prime plus w prime x prime y plus w prime y z prime plus w x prime y prime. So all in all, we have 5 inputs. 1, 2, 3, 4, 5. So w x y prime z, w prime x y prime z, x prime y prime z prime, w prime x prime y, w prime y z prime, and w x prime y prime. Here, drag it first so that I will connect here. Sorry. I will first move so that it's not hard for me. And we'll connect the here. Then let's have the what we call this, the fifth equation. Fifth equation is have two inputs. So now I will use only two. Only use two inputs here. Have E. So for equation E, let's have x prime y prime z prime plus w prime y z prime. Then I will connect it here. There we have the sixth equation, which has 4 inputs. So I will also use here the 4 input OR gate. Then I will level it. We have letter F is equal to x prime y prime z prime y prime z prime plus w prime x y prime plus w prime x z prime plus wx prime y prime. So x prime y prime z prime w x y prime w prime x z prime w x y prime. Let's sorry. So let's connect it here. Sorry. Then for the last equation, we have for letter G, we have also 4 inputs. So I will use also the OR with 4 inputs. So here is G is equal to W prime X prime Y plus W prime X Y prime plus W X prime Y prime plus W prime Y Z prime. So now, since I have now the equation, so it's easier for me now to connect it using the AND gates. So I'll connect it here first. Then I will have the ground. here. So now that I have the different equations, so first I will connect the letter A. So since we have here the W prime Y, so I will use the AND gates with 2 input. 74 LS08. Put it here. Then I will write so that I will not be confused later. I will put the name at the top. W prime Y. So W prime Y. So I will connect this prime here. Then the Y. Y is here. This is the Y I will connect here. Then I will connect it here. Then we have X prime, Y prime, Z prime. So since it has a 3 input AND gate, so I will use also 3 input. Here the 74 LS11. So I will use it here. Then I will put the label X prime, Y prime, Z prime. X prime, Y prime, Z prime. X prime, Y prime, Z prime. Then I will connect X prime. Right. Oh, I will so that it's easy for me. I'll align here. X prime, then Y prime. We have Z prime. Then it here. Then I have W prime X Z. So it has 3 inputs also. So I will also use here. I have W prime X Z. W prime X Z. W prime X Z. Here. So W prime it has here. Directly connected here. W prime X. Since this is the X here. So I will connect X right here. X. Then Z. Have it here. So here. Then I will connect the output. Then next I have W X prime Y. So I also use the 3 input and get it here and put the label W X prime W X prime Y prime. Okay. So this is the way that will connect these different what you call this wires. I will put first the gate that I will be using, then I will put the label so that I will not be confused. Then after that I will time lapse it because it is at times consuming. So that's all. I will connect it now. So later I will test the functionality after that. After I will connect it all and all. So So now, since I finished to connect all the gates, let's see the functionality. Let's test now the functionality of this 0 to 9 count. So on it. So 1. Then if I click it for the second time, it will proceed to 2. So 2. Then next is 3. So if I click another one, so 3. Then if I click, the output will be 4. So if I click another one, the output will be 5. So if I click another one also, the output will be 6. Then if I click, the output will be 7. Then if I click, the output will be 8. Then if I click, the output will be 9. So after this, since it is only 0 to 9, so after this output 9, once I click this button, the output should be go back to 0. So let's see. So if I click the button, supposedly the output will be coming back to 0. So since the output is back to 0, so therefore our schematic diagram is correct. So all in all, this is my schematic diagram for the 0 to 9 counting using the flip-flop. So that's all, sir. Thank you. And I will now give this schematic diagram to the documentation. So thank you, sir, and God bless.